Hi, everyone. So in this video lesson, we're going to cover the data sufficiency questions on in the quantitative section on the GMAT. Data sufficiency, unlike problem solving, doesn't really ask us to find the value of a certain variable, even though sometimes the questions could be phrased very similarly. But in essence, it doesn't really ask us to solve for an unknown quantity or an unknown variable. It's only asking us to evaluate information to see that if we have sufficient information to answer the question at hand. So here we have an example. If Oliver is twice as old as Dimitri, how old is Oliver? So this is our question. Right? So it sounds like it's asking us to find Oliver's age, but then if you look at the questions more carefully, it's actually providing us with two more statements. Number one, Samuel is 4 years younger than Dimitri. And statement two, Samuel will be 11 years old in 5 years. So providing us those two statements. Right. So as you look at the answer choices, it's not giving us values for Oliver's age. It's actually giving us very different information. So answer choice A goes, statement 1 alone is sufficient. Statement 2 is not sufficient. What it's trying to say is that if we find that the information in statement 1, Samuel is 4 years younger than Dimitri, alone is enough to answer the question, how old is Oliver? Then, and the information in statement 2 alone, Samuel will be 11 years old in 5 years, is not sufficient to answer how old is Oliver, then we would select answer choice A. And on the other hand, if we find that the information in statement 1 is not enough to figure out, alone is not enough to figure out Oliver's age, but the information in statement 2 alone is enough to figure out Oliver's age, then statement 2 alone is sufficient. So that would be answer choice B. Right. Okay. And then similarly for answer choice C, D, and E, we select scenarios where we find we evaluate the sufficiency of these two statements. Okay. So as you can see, to answer these questions, we might not really need to go all the way to find Oliver's age. We only need to know that, okay, to find Oliver's age, what we need to do, and do we have the necessary input to get to that question, to get to that answer, right? So say statement 1 gives us that Samuel is, let's say S is Samuel's age, is 4 years younger than Dimitri. So D is Dimitri's age minus 4, right? And then we need to find the information for Oliver's age. But then we only know Samuel's and Dimitri's age. We don't know how these two ages relate to Oliver. So we don't really know how to calculate Oliver's age here. So it's not sufficient. For statement 2, Samuel will be 11 years old in 5 years. So Samuel's current age plus 5 equals 11. So then we can find Samuel's age. We forgot one information at the beginning, that Oliver is going to be already twice as old as Dimitri. Okay. But then again, for statement 1, we don't know Samuel's age, and therefore we don't know Dimitri's age. And if we don't know Dimitri's age, then we don't really know Oliver's age, right? And then for statement 2, we now can calculate Samuel's age, which is 6. But then we don't know from Samuel's age how we get to Oliver's or Dimitri's age. We don't know that. So once again, it's not sufficient. So then we have to combine them to find Oliver's age. And then we know that we can combine them and get to Oliver's age. We don't really need to calculate Oliver's age. We just know that we can find that value, and that's good enough. In general, for these data sufficiency questions. Okay, so that is an example of these data sufficiency questions. And you can see that the answer choices a little bit verbose, but the answer choices stay the same across all different data sufficiency questions. Statement one, same answer choice A always goes, statement one alone is sufficient, but statement two alone is not sufficient. And then same for B, C, D, and E, right? Okay, so to remember these 5 answer choices, you don't have to read them over and over and over again as you go through these data sufficiency questions. Here's a quick rule of thumb. 1, 2, TEN, 1, 2, 10. 1 for answer choice A, 2 for answer choice B, T for answer choice C, E for answer choice D, N for answer choice E. So what does that really mean? 1 for A means that statement 1 alone is sufficient and statement 2 alone is not sufficient, which is what answer choice A says in every data sufficiency question. Statement 1 alone is sufficient, but statement 2 is not sufficient. Okay. All right, and then 2B, what does that mean? It means that statement 2 alone is sufficient, statement 1 alone is not sufficient, which is what answer choice B says. T for together. For answer choice C, what does that mean? It means that 1 or 2 alone is not sufficient, but together they are sufficient. E for each, and for answer choice D, what does that mean? It means that each statement alone is sufficient. You don't really have to combine them to answer the original question. And N for E, what does that mean? N, neither. For answer choice E, what does that mean? It means that neither answer choice alone is sufficient. Neither is sufficient. And even when you combine them together, they're still not sufficient. So that's a kind of tip to remember these 5 answer choices to avoid kind of reading them through over and over again as you go through the data sufficiency questions. But usually with enough practice, you're going to remember them. All right. The second thing I want to cover here is the 2 kind of subcategories of data sufficiency questions. And the 2 subcategories are value questions and then yes and no question. What does that really mean? All right, so for example, if I have a question that follows, what is X? And I give you 2 statements. Statement 1 is 0 is less than X and X less than 1. And statement 2 is X plus 3 equals 5. Okay, so this is a value question because we are asked to find a value, a variable. And for these value questions, what constitutes sufficiency, or what is considered sufficient, is when it allows us to find only one value for the variable or for the quantity that is being asked, right? So if we find only one value for X, then that means we have sufficient information. But if we find several values, possible values for X, then that would be insufficient. So for example, for statement 1 alone, we see that 0 is less than X less than 1. So there are so many possible values for X here. It could be 0.5, 0.7, 0.9, or 0.85, etc., etc. There are no restrictions for X here other than being between 0 and 1. And because there are so many potential values for X, this is insufficient. Statement 1 is insufficient to answer the question, what is X? What is the value of X? But with statement 2, we have X plus 3 equals 5. So we can easily calculate X as 5 minus 3 is 2. And there's only one value here. And because there's only one value, so this is sufficient. This is sufficient. So then in this case, the answer choice we're going to select is going to be B. Statement 2 alone is sufficient, but 1 alone is not sufficient. All right, so that's the core of value questions that we need to pay attention to when we go through these type of questions. All right. The second type of question is called yes-no question. Yes-no question. So what does that really mean? It means that questions that the answers to such questions would be yes or no. For example, if a question asks you, is X greater than 0? And then you have 2 statements. Statement 1 is X is greater than 2. Statement 2 is X is less than -1. So for these yes-no questions, if your answer is always yes, or if your answer is always no to that question, then that still counts as being sufficient. So what does that mean? For statement 1, x is greater than 2, and because 2 is greater than 0, so x is always greater than 0. It means that the answer is always going to be yes, x is greater than 0. So because it's always going to be just yes, this is sufficient. There's never going to be a value of x satisfying statement 1 here that makes x less than or equal to 0, right? X is always going to be greater than 0. For statement 2, because -1 is less than 0, and because x is less than -1, so x is always going to be less than 0. So then the answer to the question here is going to be no, and it's always going to be no. There's not going to be a value of x that is going to be greater than 0 as long as x is less than -1, right? So because the answer is always no in this case, is also sufficient. This also counts as sufficient. So then for this particular question, the answer choice you're going to select, the correct answer choice is D. Either statement alone is sufficient, and you don't really need to combine them together to answer the question here. Is x greater than 0? All right. But say same question. Is x greater than 0? But then we have this following statement instead. -1 is less than x less than 2. So what happens now? In this case, we can pick out several values for x, and we see that suppose x equals -0.5. Then in this case, x is less than 0. And in this case, the question, the answer to this question is no. X is not greater than 0. But if x equals to, say, 1.5, then x is greater than 0. Then the answer becomes yes, x is greater than 0. Now, because we both have the no answer and the yes answer for the values of x in this range, in this statement, it becomes insufficient. The answer is no longer always yes or always no. It becomes maybe now. Maybe if x is -0.5, the answer is no. But if it's 1.5, the answer is yes. So because it could be yes, could be no, is maybe, it becomes insufficient. So in that case, this statement is insufficient. So you're not going to select the answer choice that says this statement is sufficient, right? So that's the thing that we need to pay attention to for these yes/no questions. All right, and then the final thing I want to cover is the general approach for data sufficiency questions. So for those previous examples, we kind of subconsciously did it, but now let's generalize it a little bit further. Given the question, the first thing we want to do is to evaluate whether this is a value question or a yes/no question. And the reason we need to do that is to figure out what it means to be sufficient in this case. And as I explained earlier, for value question, it's sufficient when you have only one value for the variable, for the quantity being asked. For yes/no questions, if you can always answer yes or always answer no, not maybe, then it is sufficient. All right. So what we're going to do next, after we evaluating value or yes/no question, we're going to evaluate each statement individually, separately. So first, we're going to evaluate statement 1 separately. We're going to ignore what's being said in statement 2. And there are two potential cases here. Statement 1 alone would be sufficient, or 1 alone is not sufficient. So if 1 alone is sufficient, we go move to the next step, which is evaluating statement 2 separately. So now we're going to ignore what is said in statement 1 and evaluate statement 2 separately. And now there are two cases here. One is 2 alone is sufficient, and the second case is 2 alone is not sufficient. All right. So if 2 alone is sufficient, and we also have statement 1 alone is sufficient, the answer choice is going to be D. But if 2 alone is not sufficient, but 1 alone is sufficient, then the answer choice is going to be A. And now in the case that statement 1 alone is not sufficient, again, we still have to evaluate statement 2 separately. Now we ignore what is said being said in statement 1. We only focus on the information in statement 2 for now. So again, two cases. One is 2 alone is sufficient. So now we have statement 1 alone is not sufficient. Statement 2 alone is sufficient. The answer choice is going to be B. Now, if statement 2 alone is not sufficient, and we have statement 1 is also not sufficient, what we need to do next is we need to combine these two statements, 1 plus 2, and then two cases, right? So if 1 plus 2 is sufficient, 1 plus 2 is okay, the answer choice is going to be C. But if they are not okay, they are still not sufficient, then the remaining answer choice to pick is E. So remember that as you first practice these data sufficiency questions, take it slowly. Don't try to rush anything. Go through the steps. Try to make sure that you are evaluating first each statement separately, and then if each statement is insufficient by themselves, you combine them to see if they're sufficient. All right, so that's it for this video. And then in the next videos, we're going to get more examples now to get more familiar with this.